All right, Honors Algebra 2, here we are in your game plan 4.4 to 4.6. We are in section 4.5 here, and it's called Completing the Squares. This is actually a pretty quick section that has huge implications for when you are in pre-calculus and if you see me again in calculus. So what I have here is I got 4 examples, and maybe you've tried them already, of factoring, and they all have something very special in common. All right, so first off, how do I factor this? Well, it multiplies to 36 and adds to a negative 12. That is a negative 6 twice. X minus 6 times x minus 6, or x minus 6 squared. Interesting. Well, multiplies to 64 and adds to 16. 8 and 8, or x plus 8 squared. You might hear a mischievous little toddler upstairs crying. As all solid YouTube videos have. Pay that no mind. What multiplies to 25 and adds to 10? 5 and 5. X plus 5 squared. I'm beginning to see a pattern here, Mr. Yak. What multiplies to 9 and adds to a negative 6? X minus 3, x minus 3. A negative 3 twice. X minus 3 squared. All right. So, folks, here is the big deal. Our goal is to get this sort of situation, because we can solve something that can't factor, especially since we don't know the quadratic formula, which is coming in section 4.6. All right. Here is what I want you to do. Let's take a look at a positive middle term and a negative middle term. Take half of 16. What is half of 16? Ooh, 8. Square 8. What's 8 squared? Oh, man. Take half of negative 6. What's half of negative 6? Negative 3. Square negative 3. You get positive 9. Look at that, folks, and that is what you do to complete the square. So on 5 through 8, it says find the value of c that makes each trinomial a perfect square, then writes the trinomial as a perfect square. All right, so here's what we're doing. My goal is to have c be some sort of number so that I go from this, a trinomial, 1, 2, 3 terms, into a perfect square. Something squared. A perfect square. Okay, so what we're going to do is, like I showed you here, if you take half the middle term and square it, you get that c. So I take half of 8. What is half of 8? Again, go to the middle term. I take half of 8. Half of 8 is 4. I take 4 and I square it. I take half the middle term and then I square that number, and that is c. What multiplies to 16 and adds to 8? It's always half the middle term. It's always this, x plus 4 squared. I take half of 16 and I, first off I take half of 16, which is 8, and then I take 8 and square it. So c is 64. What multiplies to 64 and adds to 16? 8 and 8. X plus 8 squared. I take half of negative 12. Half of negative 12 is a negative 6. I take negative 6 and I square it. I get 36. C is 36. What multiplies to 36 and adds to negative 12? Negative 6 and negative 6. X minus 6 squared. And lastly, here on 8, I take half of negative 10, which is negative 5. And I take negative 5 and I square it. C is 25. What multiplies to 25 and adds to negative 10? X minus 5 twice. It's always half the middle term. X minus 5 squared. Take a look at number 9. It's the same as 5 through 8, but, oh, man. Take half of 7, you get 3.5, and no decimals allowed. Half of 7 is literally just half of 7. 7 over 2. So I take 7 over 2 and I square it, which means I square 7 and I square 2. I get 49 over 4. That is C. What multiplies to 49 over 4 and adds to 7? Well, it's always half the middle term, so it's x plus 7 over 2 squared. You'll see that next year in pre-calculus. 7 over 2 plus 7 over 2 is 14 over 2, which is 7. Check. 7 over 2 times 7 over 2 is 7 times 7, 49 over 2 times 2, 4. It's 49 over 4. Check. All right, so you'll have some weird numbers there as a center or vertex. You'll see where this is heading in a second. Probably next year in pre-calculus, we'll try to keep the middle term an even integer this year. All right, and then we're just going to do one page here. So first off, if x squared, let's say the situation where x squared equals 9, solve for x. X could be 3 because 3 squared is 9, or it could be negative 3 because negative 3 squared is 9. So X is plus or minus 3. Another way I could solve it is I could take the square root of 9, but don't forget about the plus or minus, because we know that if x squared is equal to 9, negative 3 and positive 3 give me 9. So why is that important? Because we're going to see it here. Solve each equation by completing the square. Folks, if I gave you this situation and you don't know the quadratic formula, which you don't for about a week only, what multiplies to 11 and differs by 4? There's only one way to get 11. That's 11 and 1. 11 and 1 differ by 10. Oh no, this literally doesn't factor. Oh boy. So what I'm going to do is I'm going to try to figure out how to solve this. The only way I can, I'm going to add 11 to both sides. All right, so I am going to complete the square. I got x squared plus 4x is equal to 11. All right. And how do I want to solve this? First off, I am going to take half, and you'll see why. Because, you know, if I had this situation, like x squared plus 1, x plus 1 squared is equal to 9. If I had that situation, I'd be like, oh, I'll take the square root of both sides. I'll have x plus 1 is plus or minus the square root of 3, and then I'll say x is negative 1 plus or minus 3, and I'll get two answers from that. Okay, you'll see that in the quadratic formula here soon. So what I'm going to do is I'm going to add 11 to the other side. Then I'm going to complete the square here. I'm going to take half of 4, which is 2, and I'm going to square it, plus 4. Well, I'm going to add that right here. If I add 4 to the left, I got to add 4 to the right. 11 plus 4 is 15. X squared plus 4x plus 4, that factors to be x plus 2 squared. Anytime I have something, an x that is squared, and I want to solve for it, well, I'm going to take the square root on both sides. When I take the square root of something that's squared, these two operations undo each other, and what is inside the square root just falls out. Okay, so I have x plus 2 is equal to the, again, from here, if I had x squared equals 9, then x is plus or minus 3, plus or minus the square root of 9. This quantity squared could have been originally negative root 15, because when you square a negative root 15, you get positive 15. And this originally could have been, obviously, positive root 15. When you square positive root 15, you also get 15. Okay, so I have x plus 2 is equal to plus or minus the square root of 15. I want x all by itself, so I subtract 2. I put the negative 2 in front of the plus or minus. Now, you don't actually have to use completing the square at all this here to solve equations. You can use the quadratic formula, but this is how, and we'll kind of see how this leads into quadratic formula. This gives answers that are very much similar to what we'll see, but that's why we're just going to do 4 of these. Okay, so again, what multiplies 29 differs by 10? Nothing. So I add 29 to the other side. I take half of this middle term, that's negative 5. I square negative 5. If I add 25 to the left, I need to add it to the right. I have that written down there twice. This is 54. What multiplies 25 adds to a negative 10, x minus 5 twice. If I want x all by itself, I take the square roots. This falls out of the square root. X minus 5 is equal to plus or minus root 54. Now, some of your calculators would tell you that the root 54 is 3 root 6. All right. Add 5 to both sides. 5 plus or minus root 54. I'm going to add 14 to both sides. Okay. I take half of, because if I ask myself what multiplies 14, it differs by 6. 7 and 5 are so close, or 7 and 2 are so close, but they differ by 5. I take half of negative 6, which is a negative 3. Negative 3 squared is 9. I add 9 here. I add 9 there. What multiplies 9 and adds to negative 6? X minus 3 squared is equal to 23. Then I take the square root of both sides. X minus 3 is equal to plus or minus the square root of 23. And I add 3 to both sides. All right, again, this is a method you might like. Definitely the quadratic formula more. I could have moved the 7 over and asked myself what multiplies to 7 and differs by 2. Nothing. So I take half of 2, which is 1. I square 1, still 1. I add 1 in here, so I add 1 here. X plus 1 squared is equal to 8. I take the square root of both sides. I get x plus 1 is equal to plus or minus root 8. That's plus or minus 2 root 2. You can leave it like that. I subtract 1 from both sides. X is equal to negative 1 plus or minus root 8. A little preview to pre-calc. So this is the equation of a circle with center HK and a radius R. This is the equation of a circle. And we are going to talk about this at the very end of the year. You also have a pretty sweet chapter in pre-calculus covering counting sections. What we're going to do is complete the square twice. So this negative 17 needs to be moved over. And I'm going to give space. I'm going to put all the x's together, space, the y's together, space. All right. So I'm going to complete the square. I take half of negative 8, which is negative 4, and I square it. I added 16 to the left. I add 16 to the right. I take half of 4, which is 2, and I square 2, which is 4. What multiplies 16 adds to negative 8? Negative 4. What multiplies to 4 and adds to 4? 2. So x minus 4 squared plus y plus 2 squared is equal to 37. And that is the equation of a circle. In standard form, it's always the opposite because it was, you see this, x minus h, y minus k, and the center was hk. So the center is 4, negative 2, and the radius squared is 37, so r is the square root of 37. The radius is just bigger than 6. Okay, folks, this is it for that part of the notes. Now, I do want to say, as you know, now this one might be on the quick side here. I told you just have these answers ready, okay? So we are going to talk about section 4.6 when I'm back, when we are back from Thanksgiving break, while also talking about this quiz review. All right? So 1 through 5, write each function in standard form. I just did a little distribution. I'm going to go a little bit quick through this, so pause it if you need these answers. Write in standard form, x squared first. Here, FOIL, take 3 and I square it. Now, I also FOILed it over here, but the trick is take the first term and square it. The inner product is a negative 6x. If I double it, I get a negative 12x, and you see it here. Minus 6x is a negative 12x. Then I take negative 2x and I square it. That happened over here. And then plus 9, put it in standard form. And 5, first outer inner last, plus 5x. Okay, and I just wrote that in proper standard form. Again, pause this whenever you need to. So I'm going to go a little on the quick side. So 6 through 9 was state the vertex. State the vertex. And I don't ask you whether it's a min or a max. I just say state the vertex. So about negative b over 2a. Middle term's b. What's attached to x squared is a. Negative b over 2a. The opposite of b. The opposite of 4 over 2 times a negative 1. And that's 2. The x-coordinate of the vertex is 2. I'm going to plug that in for x there, and my y-coordinate of the vertex is a negative 6. My vertex is 2, negative 6. Number 9. Negative b over 2a. So the opposite of 12, all over 2 times 2. X-coordinate of the vertex is negative 3. I plug negative 3 in for x. All right. That looks good. 10 through 17, you simply FOIL. First, outer, inner, last. Draw the arrows first, outer, inner, last. It's all about multiplication. All right, again, you can do this in your head. X squared, and then 5x, 3x, and 15. All right, x squared plus 8x plus 15. 16x squared plus 12x minus 12x minus 9. The 12x's cancel. That's an interesting situation. Kind of the same thing as what's up there. I have the door closed, so hopefully you can't hear the chaos that is going on upstairs. All right, 5x squared minus 20x plus 3x minus 12. Negative 17x is the middle term. All right, and we are rolling. So I did the whole right side. Factor, do not solve. Don't tell me what x equals. It equals nothing. There's no equation. What multiplies to 14 and adds to 9? X plus 7, x plus 2. What multiplies to 36 and adds to negative 12, negative 6, negative 6? That's a perfect square. What multiplies to 48 and differs by 2? Negative 8 and 6, or 8 and 6 do that, and 8 is negative. All right, I'm going to do 25 with you. All right. So there's only one way to get 3x squared. This is guess and check, and we did a pretty good job with that. There's only one way to get 3x squared. It's 3x and x. So let's think about some factors of 21. Probably 7 and 3, right? Probably 7 and 3. Positive, constant, negative middle term. Positive, constant, negative middle term. That means both of these factors are negative. Negative times a negative is a positive, and a negative plus a negative is a negative. All right, well, if I guess 7 and 3... let's be smart. The 3 can't go here because 3 and 3, I'd have to factor it more. That's not simplified. That will never be the case. All right, so it's got to be this if 7 and 3 are going to work. Negative 9x. Oh, minus 7x is check. Negative 16x. All right. Oh, no. What is this one going to be? Well, there's only one way to get 3. There's 2 different ways to get 4x squared. It's either 4x and x or 2x and x. There's only one way to get 3. Now, here it is. This is 2x, and this is 6x. Can 2 and 6 become 4 if one of them is positive and one's negative? Yes. All right, if you put 3 here, you get 3x. Put it there, you get 4x. 3x and 4x are going to be plus or minus 1. If you put the 3 here and the 1 there, you'll get 12 and 2, and that's going to be plus or minus 10x. So it is this one right here. Remember, there can only be one answer. What multiplies to 30 and differs by 1? X minus 6, x plus 5. All right, so that was that page, and we keep on rolling. I'm going to try to make this right at a 20-minute video. What adds to 20, or multiplies to 20 and adds to a negative 9? X minus 5, x minus 4. Set them both equal to 0. Those are your 2 solutions. Take a look there at your next 2. What multiplies to 32 adds to a negative 12? X minus 8, x minus 4. What multiplies to 72? It differs by 1. X minus 9, x plus 8. Again, cover-up method. X plus 9 is 0. X plus 8 is 0. What multiplies 25 and differs by 0, 5 and 5. 1 is positive and 1 is negative. All right, hopefully you practice 38 and 39. That's how that factors. Negative 5x minus 6x is a negative 11x equals 0. Those are your 2 solutions. Given the roots, write the quadratic equation. If x equals negative 3, then x plus 3 is a factor. If x equals 8, then x minus 8 is a factor. And FOIL it. All right, I'm leaving the more challenging ones for us to do in person. Write it in standard form. So what I did is I took this and I FOILed it. And then I multiplied by negative 5. And then I just added the 6x and the 35x together. So take a look at that. We'll talk about 44 when I see you again. And 46, factor. What? How do I factor 46? What do they have in common? They're both multiples of 6, and they both have an x in common. So again, to factor means to divide out. 6x squared divided by 6x is x. 30x divided by 6x is 5. Divide both of these by 4. I'm left with x squared minus 36. Well, it multiplies to 36 and differs by 0. Positive 6, negative 6. With the 4 on the outside, you got to leave the 4 there because you don't have equals 0. So it's not an equation. You can't divide both sides by 4 because they're not 2 sides. That's just an expression. The 4's got to remain. All right, and 50 is kind of interesting. The y-intercept is when x is 0, so let x be 0. It's pretty easy. The x-intercept is when y is 0, so let that be 0. I have an equation, so I can divide both sides by 3 and say bye-bye to them. X plus 2 squared means x plus 2 times x plus 2. Just do the cover-up method once, and x is equals to negative 2. This video is just going to be under 20 minutes. Have a great Thanksgiving break. I'll see you on the 29th. This is Yak Math Videos, signing out.